this computer, share the screen. Okay, let me see. Okay. Okay, here that you saw that when it comes to that week one, I hope that you have already seen the syllabus and all this stuff. Because in the syllabus we were talking about that we have to cover the 11 chapters at 11 chapters, 3 chapters a week. That's a lot. Okay, so don't freak out. Okay, don't freak out. Don't be frustrated. Don't get panic about anything because I'm here to help you out. Okay, because we have a plan. Because that's what we're going to have that office hours on Wednesdays to go through all homework with you. Okay, I'm going to help you out to that do all homework and your midterm and final exam and all kind of stuff. Okay, so in addition to that time that you can schedule a time if you really need that one-on-one some kind of a discussion or that help, you can anytime you can schedule that one. Just shoot an email and then we can set it up. Okay, so here that look at go to week one. Week one, they were talking about so many things. Okay, week one lectures here, week one practice, some practice exercises here, week one discussion, 1, 2, 3. In addition to doing that, your homework, you have to just answer this one too. Is a part of that your grade. What I'm gonna do to make me flexible with you, that this part I'm not gonna skip, but if you want, you can go ahead and fill this in. If whether you're gonna do this one or not, I'm gonna give the grade. Okay, because I want you to mainly focus on your contents. Material and the programming rather than that just to answer these questions. Sometimes it's time consuming for you to get these 3 done. Okay, not only these 3, that every week has like that kind of a discussion. So if you want, you can then go ahead and then do the discussion. Whether you're gonna do it or not, I'm gonna give the grade. Okay, that's the first thing. And the other one, if you see that anything that, let's say that week one assignment, let's go to week one assignment. This is going to be due by this coming Wednesday, Sunday. So I have to change this. Oops. What happened? Week one. Okay. Week one assignment. You see, if you see that, see here there are heavy rubrics and everything being added over here, but don't worry about your writings. If you want, you can write in detail. Okay, I don't have anything against that one. No, I'm not gonna. I'm gonna give the points for that when you do a good job. Mainly that what I'm focusing on. I want you to that add that coding and some kind of a some explanation for that your answer. Sometimes you don't have explanation, just the answer. Let's say here that generate scatter plot matrix for the following continuous variables. Just show the scatter plot as well as that the code. I want to see the scatter plot matrix as well as the code come along with that your answer. Okay. And if you have to test it, there are, see, if you want to run this test, state the conclusion, you can elaboratively write the answer. That's okay. But I'm not going to stick to that, all these, and then say based on that one, I'm going to give the points. No, no, there's no such thing. I'm going to give the full credit for that when you do a good job on that, maybe that coding and then the results. Okay. So that part I have to tell you to ahead of the time. Plus, even though we have a deadlines, okay, to be flexible with you, deadlines, don't worry about the deadlines. Okay, sometimes you are really busy with that your work and everything, and then your other things. Take your time and finish all homework, all that assignments. Make sure you're gonna turn in everything before end of this term. Okay, I'm gonna give that chance for you to that. Let's say that I don't have any strict rule on that collecting that all homework at the end of this week. Okay, no, the homework one, no. Okay, so if you need more time, take your time and just finish it and make sure to that turn in all homework before end of the semester this term, like that means end of October. Okay, before, of October, means around like a 23rd, or that may be end of, because even the last week I'm going to give you for you guys to do the finish final exam. So those concessions are already given to you. Make sure that we really need to do a good job on that one. I want you to not to freak out, just hanging on over here. Okay, the content sometimes that sometimes you might have seen, sometimes you might not, but doesn't matter. You can learn. Okay, you can at the end of the day that because I'm gonna do this one in the broader range and then in a vast scale for you to have a strengthen your that the statistical skills or tools at the end of the day for you to utilize in this data analytics. Okay, and don't have even the wrong notion that data analytics is the just merely that get the data and analyze and give it back to the client or the your boss or the layman. No, it's come along with the like so many things, because everything that you're going to do in data analytics or data science, you have to utilize the statistical tools. You better learn all the tools, not in like a heavily theoretically. We don't do like that, because that's why we are using the programming. Program will do that one, but still you have to get a little bit of clear idea what's going on behind that, all the programming. That's very important. Okay, so I think we're not going to do anything rigorous. Mainly we're going to cover the regression. I think you have seen regression in 605. Because I just finished 605 and 600 and 605. And in both classes, we just laid a very good foundation for you guys to move forward and then finish the regression in a elaborative way. Okay. So I think you have seen the models, you heard about that word regression, and you know when the regression is being utilized. It's a part of the data mining, and the regression is a part of the supervised machine learning. Okay. So those things, I think you have already heard. If you haven't heard about that one, even that I can just work with you and then lay down a good foundation in this class. Okay. With that said, okay, that's about the homework, final exam, test, all that midterm test and all these things that don't. I don't stick to that. I don't have any strict rule on that deadlines. Okay, so make sure that you're gonna turn in all your everything, and based on whether that you turn in, I'm gonna put the grades for you. Okay, if you're gonna turn in that end of this week, that I can just put the grade. Okay, so with that said, let's see what we have to talk about. Yeah, then mainly that, sorry, go to week one, and then in week one, you see this one, week one lecture. Here you have some PowerPoint for that week one lectures. Like that. In addition to that one, there are extra ones too. I'm going to add the extra ones too in addition to that one. See? I'm going to go ahead and add that one later on. I have that the PowerPoints come from the textbook. Okay, that means this is what I'm talking about. See, sorry, this one. See, it's come from the textbook, the PowerPoints. See, that one I can add to that place, to that module over there too. I'm going to go ahead and do that one too. So this week we are planning to cover chapter 1, chapter 2, sorry, chapter 2, see, basic stuff. Not mainly, we're not going to cover the regression, but interchangeably we can go through all the concepts. See, simple regression. We're going to cover simple regression and the basic stuff in this week, but later on in the second week, multiple regression, and then other types of regression, curvature regression, and the diagnostic. And the third week we're going to do some kind of a principal component analysis, discriminant analysis, and all kind of a third week and fourth week, those kind of a thing. Keep doing an analysis of variance. Okay, those things. So mainly that we're going to cover 3 chapters over here. So these PowerPoints can be even added here. That's what I'm going to do. Okay, so practice here is a reading. That's why they say, see, these 3. These three are available at this page, the SAS Enterprise Guide. And on the other hand, I have added under your student resources how to install that SAS if you have a Windows or if you have a Mac. Okay, so all the information now over there. I hope that you have already have SAS been installed on all your computers, and then I'm mainly working on that SAS Studio. Okay, I'm working on SAS Studio. You can work on SAS Enterprise Guide too. Doesn't matter. Okay. Try to that utilize SAS. Okay, in the that if you, for a certain reason that you cannot get this done by SAS, that R or Python, they are welcome too, but don't stick to that one. I prefer that if you're going to use SAS. Okay.
So I tried to install the image. The image wasn't available when I clicked on the Google, but it's also 50 gigabytes. I don't think my computer can support that. So you're saying it's okay to use SAS Studio, right?
Yeah. See, this one is a SAS Studio. Yeah. Oh, man. Let me see what happened. Yeah, I think that link, let me go back. Settings also there. So yeah, this is for the SAS, and that SAS, this for the SAS Enterprise Guide, SAS Studio, everything over there. So if you feel like that you don't have enough space on your computer, some of the stuff you can take out and then necessary components only that install. Okay, you can do like that. That's one way of getting this done. See. But I think that SAS Studio, that's freely available for the student, no, from the campus, no?
Yes.
What I remember,
We have SAS Studio still. I logged into mine today.
Yeah, that's good.
yeah,
Everybody.
I think in our previous class we were just sent an invite to access the files from the class.
Oh, the SAS Studio, I'm sorry, this one, pretty much everybody has this one, no? That's what I want to know.
Yeah.
Yeah, that's good, yeah. So let's work on SAS Studio and then try the codes from the scratch. In that way you can learn coding as well as all that your contents. Okay, this is gonna go, it's intertwined, because I'm not gonna do standalone just like a only programming and the material being intertwined, because of this. If you want to write something, in order to get the results, you have to know what's going on behind that one, like that. Okay, so those things we're gonna cover in large scale too. Okay, that's good. Okay, so any question before I'm gonna go ahead and just get started? That anything related to homework, related to your assignments, office hours. Okay, sorry, office hours, as I mentioned, even in my email and then announcement, even on syllabus, that we're going to meet on Wednesday, even though I say that 5:30 to 6:30, sometime I'm going to do that one, 2 hours, 3 hours, doesn't matter that as much as that I have to, let's take the time and then just finish that homework. I'm going to help you to do the homework. Let's say, for instance, I'm going to say this is a homework one. I'm going to go through all this detail with you. Or later on, whatever you can get from me, get it, and then okay, and then do your own way, and then just give the answers to me. Okay, when you run, okay, that means that let's say, for instance, that when you run this one, okay, if you want, you can have a library. We're gonna talk about these ones later on. Oops. Okay. Yeah, see, you get that. Okay, your results, let's say, go to code, here log, here you will have results, here you have output. So if you want, you can see, okay, print. It's gonna have you on the result. Yeah, you run on that one, you get the information from there, then you can get this one to like a, I'll show you something to you, how to answer the homework to up to a certain point. Yes, explain to you. Oh, that's the homework. Okay, this is the homework. So you can have the question that if you want to do like a nice work like that, see, you see, you can put the question, see, you can put the answer. Okay, whatever, if you want to give the description or something like, give that one. Give me the code like this, copy and paste here. Okay, copy and paste here. And then you can write about that one explanation related to that particular question. Then you get your like output and put it over here based on the question. See, like that. See, see, up to here, then explaining that, like that. Doesn't matter, okay? So anyhow, try to give me mainly that the code and the results, okay? But I know you guys are really good in writing that. So if you feel like that you don't have that much time to do like a just write for the writing, that's okay too, okay? But at least you should give me the code at least, okay? For how you have done, and then results should be come along with that one, okay? So other things you can add on top of that one, okay? When you want to make like a that complete answer, then you can write, okay, based on that one. See, here we were very clearly we were writing. We're going to talk about if you can write within plain English, or sometimes you can use the notation. I'm going to show all these things like that. Then you put the code, you put the results, see, put it over here like that. Okay, that's kind of like that's the best way to give me the answers. But any format will be accepted, okay? Any format, don't worry about anything, okay? I want you to learn, okay? My whole purpose here is to that teach you, and you will be comfortably that learn material, programming, contents, and then I'm not mainly testing. It's not our job actually. Not the instructor's job is not to test. You will be tested when you go outside to the society, go to a work. That's why we were here to help you out, educate you. Okay, that's I don't know. That's what I firmly believe in as an instructor. I want you to learn contents, okay, and the programming, okay. So I help you out for even to go through all the homework and everything on Wednesdays, and then you can comfortably learn the material, okay. So do you guys have any question before I'm gonna move on to just go ahead and get started? You wanna talk about?
Can you provide us with the chapter slides that you're gonna go over as well?
Yeah, sure. Yeah, that's what I say. That I'm gonna go ahead and sorry, I'm gonna add that one to the.
Okay, thank you.
Yeah. Say go to your resources, student resources. Week one reading. No, week one lecture. See, I can add. See, add from here to see those three for this week, and the next week I have all this all that PowerPoint that come along with that textbook too. So those can be, this is for chapter 4. Everything, see all the information over there. I'm gonna add today once we done with today's lecture. But let me see that add existing Google Drive, OneDrive. Oh no, all right, so okay, I can put it here, easy. I'm gonna drag it and put it over there. This is separate PowerPoint. Week one, chapter 1. Still uploading. Yeah, this is gone. Is that student resources? So week one. Yeah, you see. Yeah, chapter 1. Week 1 practice. Week 1 lecture. Week. So, okay, chapter 1. Week 1 assignment discussion. Practice lecture. Okay, the lecture. Yeah, I can keep that one below that one. Lecture that one, and then I can put all this. Chapter 2. Chapter 1. And chapter 2. Good. Chapter 3. For this week, the rest I can then upload later on. Yeah, it's coming under week 1. Oh, sorry. Oh, I have to make it available for you. Now you can see. And part 1 of that one. Can see that one. Okay, let's add the part 2 of that one. Yes. That's good. Then 1, 2, chapter 3. Good. All the information, that means a condensed, all that book has been condensed or summarized through this, all this whole book. Then later on, I'm going to add that for the week 2, 3, 4, all the rest of the chapters. Okay. So before we gonna that, the first week that we have to just a little bit refresh our memory on that some concept that we have learned about this the statistics. Okay, so let's one lecture before we go to that one. I would like to some explanation about few things, so you can remember. Write something. Okay. Some little bit notation and all kind of a thing, and then give a like a little bit idea about what we are planning to do this thing. We are trying to do something called the simple linear regression. Linear regression. You can remember before we come to simple linear regression, in the very beginning, we have a from the analytics 600, analytics 605, we discussed something like that called the empty model. Empty model. You can remember in the beginning, we had the empty model. Empty model, or we call this one null model before we come to the regression model. So in the empty model, what we did was you have x-axis, you have here y, Y, you have a variable, some variable. Let's say that I would say thumb length. Okay, thumb length. You can remember this example from that textbook. Simply, I'm going to call thumb being explained by none. Here, none. Here, none. Thumb length coming from a certain data frame or data set. Let's say that data frame is data frame. The name of the data frame, let's say fingers. That's the name. That from that particular data set, you get this particular variable, this variable called the response variable. Can you remember? Response variable or dependent variable. Dependent response or variable or dependent variable. Okay. Then you talk about only your y values only, thumb lengths only. It's not being explained by any variable, not another variable being added to x. Okay. So y, let's say that thumb has its own mean, see, own mean. I'm going to denote that by y bar. That's a notation you can remember. Y bar. Y bar is nothing but the mean or average of thumb lengths, all thumb lengths. See, y bar. So how do you get y bar? How do you get y bar? That's the notation you have to little bit get familiarized. How do you get y bar? Y bar you can get simply, let's say that you have n many variables, that n means the sample size, okay? Sample size, you can remember, okay? Sample size. You're gonna sum them up. This notation you can remember, sum. You're gonna sum all the y values and then divided by the sample size, okay? Sample size. Okay. See that one? So here we are n equals sample size. As an example, you can say n equals 147, something, 147, something like that. That's the notation. Some people, they try to use this I to indicate that index, ith person, it goes from, y goes from 1 to n. You don't have to put like that. That's the same thing you can write like this with the way that I wrote earlier, 1 over n summation y, that's enough. That's the same thing, either this way or this way. See? That notation called the sum. So the program will, when it comes to that huge, massive data, we're not going to do anything by hand, but you have to have a clear picture what's going on. See? So what's gonna happen? All the data on this axis, see, on the only y variable only. Let's say that your data, see, your data below the average or above the average, see, maybe like that. So with the aid of that one, what you did? You built up some model called, see, data equals model plus other stuff. You can remember this one. If you can remember, that's okay too. Data is nothing but y. See, the model is what? You're going to use y bar plus this one is called the error. That's why we are using statistics or data analytics, because of this guy. This guy is the key for statistics and data analytics. Up to here, this is deterministic. This part, random. And all together, you get randomized. Whole thing is randomized. That means if you're going to find that the error from, see, you can easily see error is not going to be the same. Error is what? From this one, you can easily say error is nothing but you can get the y minus y bar. See, I'm going to take the y bar to the other side. Error. See? So they denote error by e. E is nothing but y minus y bar. If you want, you can put I here for the ith person, I here not for y bar. See, for the ith individual. See? Individual. So if you go ahead and just check, see this gap, this deviation. Each and every one has a different deviation. Some are above the average, some are below the average. See, all are errors. See, error. And the interesting part, error not going to be the same for each and every individual. They differ. That difference, that variation creates a randomness. That's why we call the random. In this whole universe, that all the phenomena, all the events are randomized, not exact, not deterministic. We cannot say deterministically anything. We cannot predict anything deterministically. If that's the case, that you don't need the statistics or data analytics, because the mathematics can tackle that one. That's why we're going to use the statistics, because the mathematics cannot tackle mathematics only for deterministic part. See, this is deterministic, y bar. See, y bar is deterministic, but that's not enough for to. That's why this more abstract. But in practical application, you know that our data, anybody's that thumb length, if you're going to measure the thumb length for a given like a data set, they're going to differ above or below. Above or below, some people might have exactly the same value, but it's a very rare event. So because of that, this randomness create very serious issue. That's why mathematics cannot tackle. That's why statistics move on to that huge data set. That's why we use with the aid of that statistical tool, we handle the massive big data. When data cleaning, data, so many things we have to do, some variables, so many variables. Sometimes they might gonna add another variable to explain this one later on. That's what we are trying to do here. They say there's none. That's why we call the empty model. Empty model. Empty model is nothing but everything being explained by the average. Y is average. See, this is the empty model. Empty model is y plus y equals y bar plus error. See, that's the model. It's the model. If this model not gonna, we had a broader discussion how to see how we know that whether this is gonna be the best model or not. We ran the analysis of variance table. We looking into that one, and we were talking about so many things. And then based on that one, we built up that we decided, okay, this model is not enough for us to explain the thumb length. Then we systematically added another one. And keep in head, the y variable is always quantitative. This one quantitative. Quantitative. Or they call the numerical. Numerical. For my convenience, I'm going to use this abbreviation, cont. See, like that. You know as of now, how that data being classified. I'm going to add this one to a little bit here. Data or variable classification. How they classify mainly data going to be either qualitative or quantitative. This one has another name, categorical. For my convenience, I'm going to say cat dot. This one, numerical. Numerical. Sometimes we can say num. This one we can say cont, deviation. This one we can say call. Okay, deviation. Mainly you can, based on their numbers. If you are dealing with the numbers, it's not necessarily numbers. If you are dealing, the labels, it's going to come to here. Qualitative means the label. That let's say that you have as an example, I'm going to put just street addresses and shoe size. And then let's say that the grades, sorry, no, let's get a different one. Height and weight and temperature, okay, only few of them. So mainly by looking at the street addresses, shoe size and height here, these variables, height, okay, height, weight, anything, we can height, okay. You know which one is qualitative, which ones are quantitative. Out of that one, and the temp can be expressed in three ways. I'm going to express in degrees Celsius, degrees Fahrenheit, and Kelvin. I'm going to express in three ways, okay, for time being. Degrees Celsius, degrees Fahrenheit, degrees Kelvin. Sorry, degree, there's no degree for Kelvin for a certain reason. Out of these street addresses, shoe size, heights, and weight, and temperature, which one's going to be the qualitative? Qualitative means just the label, street addresses, just the labels. See? Street addresses, just the label. Shoe size, just the label. But when it comes to height, weight, those are involved with the numbers, and temperature for sure. Doesn't matter degrees Celsius or degrees Fahrenheit or Kelvin. Doesn't matter. See, those are numerical. And I would like to keep another one, shoe size, address. We can see gender. I'm going to add the gender to gender here too. So the gender should come here too. It's a label. So this one I'm going to categorize again, subcategorize. How? Nominal, nominal, and ordinal. Nominal means it's a qualitative variable. You can, it's just a label only. But ordinal is a categorical variable, but still that still you can order. Like street addresses. Street addresses always set up according to certain order addresses. Shoe sizes. See? You can order. See, there's a label. It contains the number. It does not necessarily to be number, has to be numerical. No, no, no. You're gonna see that a number, something like with the numbers, even the categorical things, categorical categories, you can label with numbers. It doesn't mean they are now numerical. No. You can, let's say that gender, down the road gender, we can label with 0 and 1, or 1 and 2, or 2 and 3, any numbers you wish. That doesn't mean they are categorical, they are numerical. No, they are labels. They are labels. Okay. And even the, let's say, heights. Heights, you know, you have done that one in that you were at 600 and 605. Very clearly, you can convert this into categorical. How? Instead of talking about the heights, numbers, you can say, can you give me the some three categories? Short, medium, and tall. That's categorized. See? This one categorized. This one too. You can categorize. Any numerical one, you can come back to this one too. We know how to do that one. Those two classes we handle with the R. Here we're going to learn how to get this in SAS. Okay. So here, nominal, under the nominal, you have a gender only. See, as an example, gender. So this one again, gonna divide into two parts called the discrete and continuous. I'm gonna write CTS for the continuous. Discrete means there's no any number in between any two consecutive integers, like a 1, 2. There's nothing in between, no decimals, nothing. Discrete. Not necessarily that one. Not necessarily that one. The idea is, let's say that price of an item, price of any item, price of a pair of jeans, that price has been decided gonna give up to second decimal place. Because of the second decimal place, it's not gonna be, even though it's decimals, it's not continuous. It's discrete because you cannot take as many decimal as you want to express the price of any item. Because by universal convention, we're gonna keep that one to the second decimal, except for at the two places. In the stock market, we go to the third or fourth one, and in the gas station, they go to the third one. Okay, those are like a very rare situation, but universally accepted, it should be kept to the second one. So if you add another one, let's say that price of something, okay, price here, I'm gonna put the price here too. So price would be discrete. and continuous. Temperature, weight, height, and temperature, all these gonna be continuous because they can be expressed in terms of decimal. Even though we say that in colloquially, we say the temperature like a 70 degrees, okay, 80 degrees, 90 degrees, like that. But the temperature, when you're gonna measure, that's called that the energy of that particular environment or the body called the temperature, that can be expressed with the decimals, as many decimals as you want. In that sense, it's going to be all these three of them: height, weight, and temp. All these three are going to be continuous. Okay, now this has been expressed in degrees Celsius or degrees Fahrenheit or Kelvin, doesn't matter. Now what's going to happen? This is going to go further down again. It's called what? Ratio or interval. Interval. So does with this one. I'm going to put ratio R here to call the ratio, I for the interval. Okay, then you can see. I don't have to write the whole thing. See, R. See, now you might be see that how we're gonna decide something gonna be ratio interval. You go ahead and see the zero in that scale. Zero price, would that make sense or not? Would that zero would be a placeholder or not? You're gonna see whether this one is a placeholder or zero would be a real zero. That's the one you're gonna check. Real zero or placeholder. If you go to the price zero, means that makes sense. That means the real zero. Because of that, it's gonna be under ratio. If it interval means, if it's a placeholder interval, okay, I'm going to put I for this one, I for this one for ratio variable, ratio data. Okay. Now you go to the temperature. Let's go to height, weight, zero height. Zero height means like, you know, that the person has not even been born. If that makes sense. Weight zero, person not even been born. That means they both come over here, weight and height. Weight and height, they both are ratio under that one. But which one is interval? Let's go ahead and look at the degrees Celsius. If you're going to express the Celsius or Fahrenheit, your temperature, you talk about zero temperature, but still there are temperature below that one, negative, all the way down to the absolute temperature. In temperature, if you express your temperature in Celsius or Fahrenheit, those are intervals. Those are intervals. That I'm going to write on this side. See, under that I, okay, I'm talking about this continuous one. So I, this one R. So here under this one, you get the temp. See, in degrees Celsius or degrees Fahrenheit. That means in your temperature, degrees Celsius or degrees Fahrenheit, especially in degrees Celsius, I'm going to talk about this one, this zero, below zero. It's going to be to negative 273 is the absolute one. So see, since this is not the real zero, not a real zero, it's just a placeholder. Because of that, they're going to be interval. But if you express that one, same thing, same temperature in Kelvin, Kelvin means this one is Kelvin 1. See, Kelvin 0, I'm sorry, Kelvin 0. So if you express that in Kelvin, that's going to be ratio. But you don't have to worry about that. I give like a rough idea what's going on, because that since I discussed the start of the discussion, I really want to complete that one. Other than that, you don't have to worry about, we're not going to ask you to classify, but mainly in our programming, keep in head what we will be taken into account. They will talk about the qualitative and quantitative. See, sometimes they call the continuous. See, continuous data and qualitative data or categorical data. Categorical data, when you say the categorical or qualitative, very clear. It's maybe doesn't matter nominal or ordinal. We don't go that far further, but mainly say that something with like a label, qualitative or category, with the strings, categorical, qualitative, strings, we call the that particular data type. The other type, numbers that can be added, subtracted, and divided, those kind of a thing, mathematical operations can be done. Those are compare the contrast, those things we call the quantitative, or sometimes they call integer. Doesn't matter. Those are integers. Eh? Discrete one are integer. Number of people who are going to get into a bank, 1, 2, 3, 4, 5. See, those are discrete, but still we're going to call that one not discrete. Sometimes they call integer. Okay. And even for the continuous, they call the mainly in our program. This is how they have, see, in our SAS programming, or any programming mainly. We have, see, categorical or qualitative. Okay. Or we're going to have a numeric, or they can solve the integer, or sometimes called the count. Okay, sometimes called the continuous. Doesn't matter. That's why those are the major things. Can we convert the integers into categorical? Yes. Yes, rather than, see, let's say the height. If you have the heights, row data, see, row heights data at the numerical numbers, you can convert into categorical. How? You can say short, medium, and tall, see, like that. Now it become categorical. You can do like that. It depends on the situation. Sometimes the income data, you have an income. Some people don't like to work with that numbers. They say shorten this one, group them. I don't want to go the low income, medium income, high income, like that. We should know how to do that. Those things we're gonna learn. So in the mainly that, even though we have that kind of a classification here, you don't have to worry about this thing in large scale. The mainly that we were focusing on two things, everything being condensed, all the classification being condensed and put it in two, but they can be used interchangeably as well. As you see here, see, raw data, get the numbers. You can say short, medium, tall, and then convert and make a factor. Sometimes they call the factor data. This one, see, factor data. Sometimes called strings. See, strings. Sometimes called the character data. Character, everything. See, that's the same category. This one, right there. Okay. So that's that. And then keep you in head that I'm gonna get back here. This variable, if I go to this one, the y variable always quantitative or numerical or count or integer or whatever that one. Okay, this one none. And later on, what they did was, after this one, if you get back to this discussion, using this model, this empty model, instead of using the empty model, what they did was they tried to explain that one. Okay, that's the first model. Second model, okay, second model. Oh, in addition to that one, I'm gonna tell you that you have a notation for C, y bar equals 1 over n summation y. I like to use this one. This is for what? This is called the standard deviation. Standard deviation. Standard deviation. How do you calculate standard deviation? 1 over n minus 1 summation. You get the y and then subtract this one and square. And then add them up. Add them up. You're gonna see this kind of stuff. See, this is nothing but what? See, look at that. Error. Y minus y bar is error in this case. See? Y minus y bar is the error. Error has been, see, squared and summed and divided by something called this n minus 1. For the n minus 1, we're going to call the degrees of freedom. Degrees of freedom. Number of independent pieces of information utilized for estimation. for estimation. We're going to talk about the estimation down the road for the estimation. That's what called the degrees of freedom. It's not n minus 1. One piece has been utilized to this guy. See, that one piece has been utilized to evaluate y bar. Y bar, to evaluate y bar, one piece of information is enough. When you utilize that one, you are left over with n minus 1. That's why you're going to divide by that. Look at this part. This is error. Error has been squared. Error squared and sum. This is called sum. See, this is called squared. So it's nothing but, you can simply say sum of squared error. Okay, sum of squared error. This one they abbreviated like SSE. You're gonna see that one down the road. Has been divided by degrees of freedom of error. I'm gonna put DFE. That's n minus 1 is DFE. DFE means n minus 1 here. Degrees of error, degrees of freedom. Degrees of freedom. This one I'm talking about here. S. So standard deviation is nothing but standard deviation. I'm gonna say SD. So standard deviation being abbreviated. Standard deviation being abbreviated as SD. S is nothing but sum of squared error divided by degrees of freedom of E. I'm gonna call that one. That's called the average mean squared error. See? Mean or average squared of error. Square of error. So down the road you can see S is nothing but mean squared error. See? You're gonna see this on a large scale in our discussion down the road. I'm preparing you for that this kind of stuff down the road. See, while we going through that basic stuff too, I want to add the rigor to that one too for you to get ready for that move forward. Okay. So standard deviation, and I'm gonna add another one to here. Another nice word here. Sample. Okay, sample standard deviation. Sample. I'm gonna write here everywhere sample. This one I'm gonna say sample mean. Sample mean, not the mean, not the population mean. Sample mean is y bar. You know how to get this one. You know sample this one, how to get this one. See? That's the formula, but we don't do by hand. They will calculate, but we have to have a clear idea what's going on behind that one, because sometime I'm gonna say find the standard deviation. You can go to some table and say, okay, mean squared error is same as the sample standard deviation. See? Squared error. I'm going to add something. Okay, one piece I missed over here. A square root for the whole thing. Whole thing square root. Okay. So I'm going to add this one square root. Whole thing. See? Whole thing. Square root I missed for the standard deviation. Now I'm going to say this one is what? RMSE. Why? Root mean squared error. Root mean squared error. Root mean squared, sorry, squared error, not dot, squared error. Average mean squared error and take the root. So standard deviation is nothing but anywhere, if you see in your printout, anywhere, let's say that for instance, that root mean squared error when you run something. Let me see that we something like that. See, root mean squared error. See, that's why I'm preparing you. See, this is nothing but the standard deviation. Root mean squared error. It's called the RMSE. RMSE. See, See, sum of square. See, error sum of square. See, squared. Either way, you can call this one. Sorry, SSC. I'm gonna write here. 100 here. And you can say starting reading from left to right, sum of squared error, error, error. Oh, you're gonna read from right to left, error, sum of squares. Either way, you can read that one either way. Same here, mean squared error. Mean squared error. Mean squared error like that. Okay, we can keep like that. We can say that error squared mean. You don't have to say like that, but that one you can say in both ways. Reading from left to right or right to left. Error sum of squares or sum of squared error. See, sum of squared error or error sum of square. So you're gonna see in this table on the road. See this one. Some related to homework 1 even we have. Down the road, okay, anyhow, we can see this kind of stuff. Okay, let's keep in head. So little bit get idea. See, standard deviation, how this become. You saw with that one before we move on to the first model. We were in the first model, the rough idea. Okay, so then let's go to second model called the group model. Can you remember group model? Group model, or called the categorical model. That means for this one, I'm trying to explain by X. For the X, I'm going to add something here, thumb length. That's okay. It's quantitative. I'm going to add something to this one called gender. I'm going to add gender. Let's say gender. It's on categorical. See, if you explain quantitative with the categorical, then let's say we have a female and male. See, then your data going to be here. See, for the some female data here, male data here. And then you have the grand mean for the everybody. See, that's called the grand mean now. Grand mean. Grand mean means everyone's. In addition to this one, you have something called Y bar for female, and sometimes here Y bar for male. See, female average. See, female thumb average. This one, male thumb average. See, thumb average. Now what is it? You're gonna write the same way like this model. Data equals model plus other stuff. I'm gonna say OS for the other stuff. And data means Y. What is the model? Model, I'm gonna write B naught plus B1X plus error. You can remember how we wrote this one. This X may be either female or male based on the value you have given. Sometimes you're going to denote female by 0, male by 1. Categorical. See, it has a new numbers, but they were not numerical. They were categorical. See, it has two options, male and female. B naught we call the what? Intercept. Can you remember? Intercept. B1 is the slope. In this case, B1 is nothing but this. B naught is this one. Same thing. See? And B1 is the gap between these two. Y bar F to this one is called B1. Based on the male and female, B naught is Y bar F. B1 is the gap between two averages. For this one, you did this one in large scale too. See? That discussion, I'm not going to do that discussion. here, but I'm gonna jump into the third discussion. That's what I'm trying to do. That's how we got into our discussion called the regression discussion. Okay. Then the third one is you can explain, you can see that how thumb length going to be compare and contrast and see male and female thumb lengths. Okay. You can do all the statistical analysis between these two. That kind of a discussion. When you have something like this, two groups, I'm gonna add something to two groups. Okay. When you have a two groups, okay, that's the one in the first homework you're gonna see. Those are not a regression part, okay? But let's say two groups. You're gonna compare thumb lengths for this guy, male and female. How could you gonna do this one? How could you? What kind of a things you really need for to that? Have a look at it. This one. You should know something like this, okay? I'm gonna tell you. This one. I'm gonna add one more thing to here. Look at. I'm gonna say you have a Y bar. You have a Y bar. You can remember. Okay, you can remember. You had S. You can remember. If I'm gonna square this one, I'm gonna call this one variance, sample variance, sample variance. You know the formula, but you don't have to worry. This one, sample standard deviation. This one, sample mean. See, you know, if you have a thumb length, okay, I'm gonna get the thumb length to this side, okay? Thumb length to this side if you want. That's how you're gonna draw the histogram. You can remember how you draw the histogram for that one. See, you can draw the histogram and then draw a smooth curve scheme in the top. On the this axis, you have the frequency, okay? Frequency. Frequency means I'm gonna FREQ deviation notation F number of individual for each class. These are called the classes. The class. That's the class. For each class, how many? You don't do anything by, you have the count. Sometimes they call this one count. Whatever I had for that y-axis on that first one, okay? For this one. So if you want, you know, you can draw this one for the male and female. You know how to do that one using R, okay? So that discussion we did in large scale in the previous classes. But here we're not going to go to do the graphical representation. We are trying to do something else because we are trying to move on to my third model. Before go to that one, I want to tell you something. People don't like to work with this thumb length. They really wanted to get into what? Thumb length average. Okay, that means average has an average. If you can remember that discussion from the previous classes, it's going to be very beneficial. Average, that means this kind of a thing, okay? This is what I'm talking about, get a rough idea, okay? You say that there are like a whole population of, let's say that large population of, okay, population of, let's say that your university, let's say that 11th, any university, okay, 11,000 in capital N, 11,000 individuals, okay, that's the population. Individuals. Let's say from this one, you're gonna pick a sample, or I'm gonna say pick a sample, okay? Sample one of size simple n equals 147, as I said, okay? And then you're gonna calculate its average, thumb length, okay? Thumb length average, y bar 1. This thumb length, okay? Thumb length average, y bar 1. I'm gonna call that one. I'm not gonna satisfy with one sample. Theoretically, okay? Practically, you don't have so many samples, okay? Remember, you talk about we did the simulation, bootstrapping, simulation, real data. There are 3 types. Real data, that's the data you're gonna have, handled at the end of the day. In order for you to handle those data, you surely need like a some kind of a foundation on which that you have to work on. That foundation is abstract, it's more mathematical. It's not, we don't work on that one. We work on that one, but we don't do the calculation for the population. We cannot. You know the reason why we pick a sample. You go ahead and pick a sample. If you want to find that average height of all national university students' height, you're not going to access the 11,000 students. You pick a sample of 147 students. You want to find the average that the thumb length of all national university students, then you're not going to go ahead and do that. It's first thing, it's a time consuming, it's tedious, it costs a lot. That's a key part. The third one is a cost cutting. Statistics, data analytics is a cost cutting technique. That's a big corporation using data analytics, data science, and then statistics in large scale to cut the cost because they don't want to go to by individual by individual. They take the whole thing together and then come up with the model, the best model, and then make the decision at the end of the day based on the model. Predictions, models, those are important. When we're doing that one, that will involve with so many things. Unclean data, messy data, missing data, censored data, truncated data. So many kind of data you're going to see down the road, and huge, massive data like that. Okay. So for those things to be handled, you really need that platform called the abstract platform to work on, the tools. So that's why when we pick a sample, we abstractly or theoretically, we're going to think we're going to pick this one, but you don't. You work with one sample, okay? Let's say I'm not happy with one sample. I'm going to pick another sample abstractly, okay? You can simulate this one, simulation processes. Size, same size, 147. And you're going to go ahead and then measure its height, 5/2, thumb length, okay? It's not same as the previous one. And then let's say you're going to do this one. I'm going to put the 3 dots for the continuation, 3 dots or ellipses. That's for the continuation. You're going to go to 1,000 times. Let's say you did this one, sample 1,000 of size n equals 147. You're going to get this one y bar 1,000. If you go ahead and look at these 1,000 y bars, they're not the same. They're going to be different from each one, not the y. Now we're working with the y bar. That randomness constitute what? Some kind of a distribution. That's why you can draw now histogram for not for y bar. You can draw histogram for y bar, and draw a smooth curve scheming on the top of that one. That's the one you take out and work on. Later on, no data gone. This is your model. That's the model. You work with the model, see? And we believe if you work with the y bars, putting into the histogram, and by doing this one, but you don't have that many y bars. What you did was you did this one. How you create all this? You can create all these by using bootstrapping. Bootstrap y bars or simulated y bars. Okay, simulated y bars. That's how you're gonna do that. You don't have y bars. You have one y bar, because based on your sample. Your sample is only one sample, not too many samples. You don't have one sample. That's the sample you utilize in order to plugging that values into that abstract model. Okay, so this one is called sampling distribution. Look at sampling distribution of distribution. I'm going to use this abbreviation BISN of y bar, sampling distribution of y bar. This distribution, so previous one I'm going to call the sample distribution, not the sampling. Sample distribution of y. You know how to draw histogram for that guy. You know how to draw this distribution for this guy. If you see, even though that you have only one sample, you did this bootstrapping, how to get this one, you know how to get this one. you can remember the codes even in SAS or this one, but I'm not going to do that bootstrapping in this class, but we did already in R bootstrapping, and then we created this one. But I'm trying to say you have another kind of a histogram called the sampling distribution. That sampling distribution has a center. Look at this one. If you go to this distribution on the sample distribution, it has a center. Sample distribution has a center. This center is nothing but y bar. See, sample mean. Sample mean. That's what I'm doing. But center is not enough to explain that data set. Data set graphically you're gonna present to the layman or the non-specialist or to the client. Client has no clue about the statistics or data analytics. You're gonna say this is the way how we're gonna condense our data. You have a thumb lens data, you have condensed and graphically represented, and you say center. When you talk about the histogram, you're gonna talk about a few things. You can talk about three things. You can talk about center. You can talk about the shape. You can talk about the skewness. Skewness. Center. See, center is nothing but y bar, which is sample mean. Shape. See, shape is what? Bell shape. If you want, you can say bell shape, any shape. Skewness, symmetry, like that. Symmetry. If it's non-symmetric, if you have a different kind of a shape, it may be right skewed, like a income data, right skewed. And the grades in a class, most of the time it's a left skewed. But in our class, we can make the uniform like that. There are different shapes. Okay, skewness. There's something called the kurtosis as well. Kurtosis means how pickedness. I'm going to add that one for you. Kurtosis. Kurtosis means pickedness of the data. I'm talking about when you represent the data graphically on this histogram, when you draw a smooth curve scheme in the top of that one in such a way that most of the area under the curve come under that particular curve, that's called that some area being see not being covered. That's okay. This is like an underestimated rather than overestimated. Overestimated means you're gonna just go over this one and then try to cover everything and then try to do so. That's overestimated. Overestimation, underestimation, and you have to come the real estimation. The best estimate means like something like this. Sometimes some are below, some are above, they get cancelled off. Okay, doesn't matter. But if you make it like draw a smooth curve, just to thinking that okay, I'm gonna have like a smooth curve to just to have a maximum of these ones. So the best way to that, just to draw something above all of these. No, that's an overestimation. We don't do overestimation. That creates the issues. You have to be careful when you do the data analysis and analytics. Overestimation, underestimation. You come to the best estimate. Best estimate. There are three types of estimation: overestimation, underestimation, and best estimation. You always go to the best. And skewness means like a related to that one. Yeah, but those things you can talk about that one. So your center is this one. So the shape, sorry, there's a one more shape and skewness you can get together like this. Okay. In addition to that one, there's another one called the spread. That's a key part. Spread is nothing but, see how spread, see this spread. That's the standard deviation, sample standard deviation, which is S. See, sample standard deviation will take care of you that one. That's the spread. So the spread will take care of that one. See, so those are the properties of that one. So because of that, we in the sampling distribution also have all these kurtosis. Okay, kurtosis, how pickedness, how peaked that would be. See, sometimes you see, I'm gonna write over here, see, skewness, see, right skew. This one right skew. See? Right skew or positive skew. Some distribution, see, rescued, rescued. Some are, see, uniform, uniform. Like that for that certain bank within a same that period, like let's say that within 30 minutes they get the same number of customers. Within every 30 minutes you get the same number of customers for a restaurant. That's uniform. See? These are models. See? This is for the skewness. Skewness or shape. We'll come along with that one. But if you get back to the sampling distribution, also has a center. That center, look at how I'm gonna write it, okay? Center, I'm gonna say, so the center, I'm gonna write mean of y bar. See, mean of y bar, mean of y bar is, I'm gonna denote like this, a mu y bar. See, I'm gonna write here, okay, here. Mean of y bar is, I'm gonna denote mu y bar, mu for me, see, this is for the mu for mean, mean of y bar. And then I'm gonna talk about the spread. Spread of y bar is, I'm gonna denote by sigma of y bar. See, this one, sigma for standard deviation, sigma for, it's not sample, population, okay, that's right, population, population standard deviation. Doesn't matter, it's nothing but sigma over square root 10 s over square root 10. See? That's the one I have, s over square root 10. Sample size, s means the sample standard deviation divided by square root 10. See the difference? See the difference? So this, you have this one, you have a s, you have a y bar, you have a y. See, you can remember. Then later on, I'm gonna go ahead and find the standard deviation of not, then you have y bar. Here, y bar is a random variable. This y bar is fixed here. Here fixed. This one is varying. You can remember why it's varying. Whether it's gonna go from samples. This one we varying too. See? At this, in this case, it's fixed. Now what? For this one, you need mu of y bar, which is same as y bar. Okay, same as y bar. Mu of y bar is same as y bar. I'm gonna write this one. Mu of y bar is same as this one. Sigma of y bar is s over square root 10. We don't have this one. We don't have this one. We don't have this one. That's what I'm trying to say. This is for the sample distribution. This is for the sampling distribution. Mean of y bar is y bar itself. So standard deviation of y bar is sample standard deviation divided by the square root 10. See the difference? See the difference? See the difference? Now, if you want to compare and contrast, like that first homework, okay, somewhere, okay, we haven't gone even to that homework. See? Okay, they were talking about based on that basics, the basic stuff. They said that use the t-test to accept or reject the statement listed below. There's no difference in the mileage between the front drive and the all-wheel drive. The same way here, if you want to compare and contrast, now the thumb length for male and female, okay, male and female, okay. Can you remember here we have gender here for the X. Here Y, you have a thumb. Okay. Here we have female thumb length. Here you have a male thumb length. If you want to see whether they are, see, male and female thumb lengths are the same. How do you set this up? Then you have to go to the testing. Go to the testing. That means what? You're gonna go ahead and check this. Look at how we set this up. H naught called the null hypothesis. This is coming from the testing of hypothesis. You're gonna say mu of mean of, see, mean of, who's mean? This one. Mean of this guy, female, the same as mean of male. Versus its counterpart. I'm gonna call this one alternative hypothesis. Mu f, mean of this one, mean of, they not the same. Not the same. This is versus, okay? You are testing whether average thumb length of female is same as the average thumb length of male. In order to do that one, what do you need? You need the t-test. You need the t-test. You looking into the t and some properties and decide whether this is true or false. You have done testing of hypothesis in other previous classes, I hope. Okay. So in order to do that one, you have to go to the code. Code is easy. You have to run one line. Okay. But when it comes to the results, the key part is that how to interpret the results to the client, audience, your boss, or the layman. Some people have no idea about it. If you use the mu and like this thing, you cannot do like that. See? So if you have something like this, they think you have two groups, not one group. Here, one group. You have two groups. See? Two groups in compared and contrast. It's the mean. Here, mean of y bar. This is, if you want, you can say this one. Some people, they love to write this way too. See? Mean of y is y bar. See? Mean of y bar is y bar. Mean of y bar also y bar. That's it is a fact. This symbol notation for the mean of y is y bar. Okay. For the S, they use what? This notation. Sigma of y. See? Standard deviation of y is sigma. Yes. See? Sample. Standard deviation of y is S. Mean of y is y bar. You know how to get that one? You don't do by hand. When you run that univariate, you can get that one by that command. See? Here the same thing. Here you're gonna find the mean of y bar, not y. Y bar is also y bar. Standard deviation of y bar is s over square root, not s over square root. Now we have that being something being passed to us with the same like over here, front wheel and all wheel, that mileage. See, you can say the mileage, average mileage of front wheel equals to the average front wheel of all wheel. You can put A versus, or you can write in plain English, H naught versus H. And then this is called the testing of hypothesis. Now, when you have a testing of hypothesis, see, testing of hypothesis. This one called the conjecture, sometimes called the conjecture. Okay, conjecture, proposition, anything. You're going to hypothesize. Like, let's say, for instance, in the courtroom, you're going to say that the person, the defendant is innocent versus that he's been guilty. Like that, same thing. Okay. That testing we are using heavily any field. And there's some people are that deceased or healthy, disease versus healthy. Okay. Or comparison and contrast. Here, compare and contrast. You say the average. You focus on average. You don't go to individual females. No. You're not gonna go to individual females. You're gonna say mu of y bar. Mu of y. Mu of female. Female. Here you can use the mu of male. Alpha Y bar male, Y bar female. It's the same thing. How could you gonna run the test? You know something called the test statistics. Okay, t-test. That's why. Okay, I'll show you here. When you run. We're gonna do this one. Okay. Here, I'm just giving that one in Wednesday. We're gonna do this once in class. See, you run something called the t-test. T-test, you get the data. Data first you're gonna import inside, and you're gonna see in that whole data set there are, for that particular drivetrain is the variable. Within the variable there are types. Only two types they taken into account, like that the way that I have drawn over here. Okay, let's say that our case of that the height being the categorized short, medium, tall, three categories, but we want to compare only two categories at a time. The same like that. There are three categories here: all wheel, front wheel, and rear wheel. They want to compare and contrast only two of them. Then you have to select them from that data set. And then you're going to say the class is drivetrain. The variable is an MPG. The variable means Y variable. See? And run. When you run, you get the result. Okay? You get this result. Look at the result. See? This result. You should know how to read this result. But before that one, you have to know that how to set this up. That's why that's the one that we were dealing with right now. We're going through to lay down a foundation to that, how to do that, explain that when you see that one, what we're supposed to do. So look at here. Okay, I'm gonna give it like a more elaborate explanation over here, a little bit to this one. I think in statistics, look at what I'm gonna do now. Everything has a two version. One is called the population version. The other one called the sample version. Okay. Before we run this test that I'm here. Okay. That test, I want to run the test. Before that, I'm trying to explain something. What that means, we think the population, when you draw the histogram, population female. Okay. And this is for the, let's say that you have drawn for the female. If a similar fashion you can draw for the histogram. Histogram being now represented by that smooth curve. Okay. This is your mu m. This is your mu f. They want to know whether they both overlap on each other. Overlap on this. If you draw this one, we're gonna call that one population distribution. That's the population distribution. Or population histogram. We don't draw, but we can draw by the coding, by writing coding. They use that simulation, bootstrapping simulation. If you use the like a million size that sample means like it's a population. It represents the population instead of 147. If you use the million data points, that would represent easily. You can draw all these. You can do all of these. We have learned all of this in 605 and 620 using our programming language. You can, but theoretically, I say that you have a two populations. See, you're going to compare and contrast and see whether these are the same. In a similar fashion, based on that your data you have, you can draw the histogram here for the sample distribution. See, sample distribution. Sample distribution has what? Y bar f and Y bar m. See, look at the difference. See, look at the difference. At a certain point, I say the mu f would be Y bar, but I'm gonna separate that one systematically, tell you some story. Okay. See, to more elaborate, if you're gonna explain that one, see, Y bar. Because this Y bar coming from, see, if you draw the data, the mean, this has been drawn not for y. This has been drawn for y bar. Here, this has been drawn for not for y bar in population. This has been drawn for y. That's the difference, okay? Yeah, bro. Your axis, x-axis is y. You drawn that one for thumb length. But in sample, you do the histogram for not for the thumb length. You don't do that one. You draw that one for sampling distribution. That's the one that we're going to utilize, not the sample distribution of y bar distribution, no histogram. That's the one you're going to utilize. You see, that's the one you're going to utilize. You're going to see that with the y bar f from your with the aid of your whatever you have that observed y bar f observed, you can easily get that average of the female thumb length because the data is available. You can get easily that average of that sample that male's thumb length. Same way you can get the mileage of this front drive wheel and the all-wheel drive. You can get that one. Same way that in that. You can get that one. But you're gonna, I'm trying to say this population distribution you're gonna do in population, but in the sample, you never draw the sample histogram. We don't need that one. We cannot do anything with that guy. No, that's why we jumped into sampling distribution. This guy is the key. Okay. This guy is the key. This guy is the key. This guy is the key. So when you do that one, you can see here in this printout. Okay, let's say this thumbnail, but we can at the same time a little bit talk about based on that. No, not that one. Sorry. Not that one. Not that one. Here. That's my homework. Yeah. See? Look at the all-wheel drive. Every information you have here when you run. For the all-wheel, like a female thumb length, same like that. This is like a male from thumb length. Here the two categories. See? My number of observation in that category, 92. Their average, their standard deviation. Something called the standard error, minimum value, maximum value. What's the standard error means? Standard error is nothing but standard deviation divided by this one. I'll tell you here. This one, what I wrote here, this one has a name. That one we call spread, we call this S over sigma. This one called the standard deviation of y bar is nothing but SE, standard error. Standard error. This is not the name. Standard error of y bar. Okay, I'm going to write here very clearly. Standard error of y bar. Let's say y bar, I'm going to write first y bar means S over square root 10. Then if you need the standard error, SE, okay, it's nothing but standard deviation of y bar. Standard deviation of y bar, you know, when you draw the histogram, I explained earlier. They vary that variation you put into the graphical representation, then you saw the spread, that spread called the standard. You see, this spread, see, this spread, how far? Actually, there's a point over here. This is the mean. And this point was called the point of inflection. That means that point is the place that is neither minima nor maxima. You see, minimum, maximum means rising up and then hit on this point and falling down. Or falling down, hit on this one and rising up. This mean, this max that point. If something gonna go and hit on this point and then change the course, but still going down, call point of inflection, POI. That's the point we have over here. So the distance between these two is called the standard deviation actually. You know that one. There are three of this one in bell-shaped curve. There are three on to right hand side. Above the mean, there are 3 to the low, that below the mean. Together we have 6 of them. That's why we call the 6 sigma. When you manufacture mechanical, electrical, the chemical, electronics components, you have to have the error within the 6 sigma. You know that one. Yeah, that's the way how they manufacture things. Error is a key part. Error has to be minimized. If error is beyond that cannot be controlled, they're not going to send their electronics equipment so that they keep in the warehouse for a certain period of time. They're not going to send right away. You know that one. Then they manufacture, they don't send to the market. They keep in like this, see, and then see whether they're going to survive or not. See, like that, like that newly born baby. See, same story. See, there's bathtub shape. This is called the infant stage. This is called the lifetime. This is called the decaying age. See, it's called the bathtub shape. This is the lifetime. See? Like that. So if they're gonna keep in the warehouse at this infant stage, all the electronics, electrical, they don't send in big corporation. I'm talking about this. That's the way how we get the best product. If you have a best product, that means they have followed all these procedures. That means if you buy something that just breakable within next month, or that the warranty being warranty before warranty expire, that you're gonna have some kind of that breakdown in your component, that means they don't never follow that research, or they don't do a good job in that quality control. Okay, anyhow, that what I'm trying to say, that here this standard error means a sampling distribution of that one, and then you can write that the standard error for male is standard error for that one of males. You can say sigma for male divided by their n male. See, n male means number of people in that male group. So standard error for female is nothing but female divided by square root of n female, number of people in that particular group. See? Male to female, standard error. Okay, standard error. But how could you gonna find the standard error for male minus female? That means I'm talking about standard error for y bar m minus y bar f, or y other way around. That one is something like this. Okay, that's the part we don't do by hand. When you run that one, you can see the even for the difference, you can look for the standard error as well. Okay, how could you gonna find that? Okay. You can see, no, not this one. Sorry. No, this one. See, this is for the, in this case, okay, let's get the analogy. Okay, let's say this is for the males, male standard error. Okay, see, this is female standard error. This that they are different standard error. Can get it. They calculate that one. It's nothing but something like this. Okay, I'm not gonna write here, because those are very heavy formulas. Okay, you don't need the formulas. I'm gonna give a rough idea only, rough idea. Okay, you have seen this one. See, like that. That's the standard error. That's the standard error. It's a standard error. It depends on whether you have to do one thing. You cannot come to, there are two types. See, they were doing this one, but true, but there are two types, pool or setup weight. How that can be decided? Before you do that test, you have to do this test. That's the problem. If you go back to this one, in this distribution, we have the spread. I'm gonna say sigma of F and then sigma of female. They are same thing here, S of female, S of male. You have to test and see whether these are the same first, before you're gonna go ahead and do this one, this test. you're gonna test this one, sigma f equal to sigma m or square, that doesn't matter, and versus h naught, okay, and HA sigma f not equal to sigma m. Whether their spread are the same, you check that one. To check that one, you utilize this table. Okay, this table. See, this table, equality of variances. We can go with the square. Okay, we can go with the variance mean square, and then you check those two first. And then by looking at how do you make the decision at the end of the day. Now see, you can check the variances. Okay, equality of variances. You check first equality of population variances. Population thumb variances. Okay, thumb variances. You're gonna check first. How do you check? You don't do anything by hand. You don't use the formula. We don't need. That's why we are using programming. Because in the history, people used to do this everything by hand. You don't need that one. You just go and read. Get a rough idea how to read it. That's it. How to get this done. How to explain to the audience. See, we're going to utilize this table. This table, you're looking into something called this part called the p-value. It's called p-value. Right here, p-value. They run this one by how you need in order to run this on something called test statistic. It's nothing but f. How do you get f? You're going to write the maximum of SM over this one divided by minimum of this guy. See, that's what they have done. See, max of out of the SM and SF, max, sorry. See. Even this one, see, you know this one. Let's go over here, see. Out of these two, let's say this analogy, okay, I'm going to use a male and female, okay, not related to this exact, well, let's say out of these two, what is the maximum value? 5.92 divided by minimum value will give you this value, f value. When they have f value, they believe that f value they're gonna call this one observed f, okay, observed f. They think this gonna be fitting into a distribution like this. F distribution we have done in 615 in large scale, 610 in large scale. I can remember. It's a frequency. Anytime you draw that one, this is a frequency. This F. They're gonna locate this. See, this is called the F distribution. It's a right scale distribution. Okay, we learn about this one large scale. You locate this one here, your F naught, and you're gonna see that area to the right of that one is called P value. P value is nothing but probability F greater than F naught. The standard probability of F, probability that or of doesn't matter, that F greater than, okay, greater than. That's called the P value. P value is more than enough for me to run the test. How do you make the decision? It's called the decision rule for the test. Okay, you can say if P value is extremely small or P value is less than the level of significance. I'm going to talk about this on level of significance. Okay, level of significance called alpha, alpha, which is normally 0.05. We reject H naught. We reject H naught. That's the decision rule. Level of significance has to be given. It's given. Okay, this is given. Given. See, given. In this case, but if you go back to this one, I'm here first. check for the equality. You see, it's extremely small and even less than the 0.05. We reject H naught means you're gonna say they're not the same. They're not the same. If you same, you use the pool one. If not same, you use the set-up weight. That's why if equal variances, you use the pool one. If it is unequal, you use the set-up weight. Now you go to the set-up weight and pick the p-value for other test. Then for the other test also, you can based on that. Then see, then you're gonna run based on that one. You decide that which test to be utilized to in order to make the decision about mu f equals this test. This test. See? Sorry, this one. We wrote the test. Yeah, this test. Okay. Yeah, this test. Now you're gonna say you utilize in this case in order to check the equality. Okay, whether let's say in terms of thumb lengths. Okay, thumb lengths for the male and female are the same, and in order to check that one, which one you have to go to? From this one you cannot do nothing. You go to this table, second table, and then you have two options. You, in order to get that option, you first check the equality of those two groups. You decided since this is reject H naught, that means they are not equal. They are not equal means you go to the setup rate, and under the setup rate again reject H naught. See, p value is less than for that particular test. Again the same scenario, same decision rule. See, if p value is extremely small or less than 0.05, you reject H naught. That means the thumb lengths are not the same. Thumb lengths are not the same for male and female. Okay, that kind of a thing. But these are extra one, that how these numbers coming from, that's a different thing. But I'm trying to say that this one has a enormous that the aspects behind that one, but simply you cannot, you have to have a broader knowledge to read this printouts. Okay, that's the knowledge we are trying to build up. Okay, don't freak out about the notation or anything, because you have to get used to it. That's the only thing. You, when you are in this kind of you know that statistics, data science, data analytics, they are always involved with the rigor. So when you are in that kind of that area, you should be prepared to get used to that. The rigorousness is a key part, because we cannot just ignore anything and go. When you try to explain this one, I have to tell you about this one. Otherwise, you have no clue where this coming from. I'm not going to go to F value. This F value we did in a large scale in our previous classes. How this F value comes into the picture, everything we did. But here we seem to say F value, this area we don't calculate. They calculate when you run everything. They calculate. Okay. Only thing we have to know exactly what to read and what not to read, and then how to explain. So you need this one to check whether the variances are the same for you to make the conclusion about the averages are the same. So you have a two test, one for mean, one for variances. You do two tests. Within one, you do two tests. Okay. It's called the pool one. Okay, like that. So, and then little bit go that I'm still on this one, but later on what they did was, okay, it's related to that part. The second model means like when they're gonna add the categorical variable for the x-axis. Now, if you go to the third one, is the one that we're gonna talk about in this class in large scale. Then you go to the regression model, in which I'm gonna explain. See, your thumb length, which is y, which is quantitative variable, with the aid of another quantitative variable. Let's say height. Quantitative variable. Again, see, we haven't categorized height. Then you're gonna have something, your data being scattered all over the places like this. This is called the scatter plot. See, two variable at a time. If you do for all the variables one at a time and then put everything together, we call the scatter plot matrix. That's what they were asking for in question number 1 in homework. Okay. Anyhow, let's focus on this one, only one. And then, you know, the interesting part, when you have a data like this, what are you going to do now? You're going to see, you have a data for each and every individual, see, everywhere, scattered all over the places. Now, what are you going to do? How come you're going to build up the model? What's your model here? What they did was they drew a straight line at the very beginning, okay? Very beginning. You might be thinking, why we go to the straight line, not gonna have, we're gonna do the best job. Yes, they're not gonna do the best job, but we have to learn about that one in the very beginning. Okay, straight line, that might gonna cover pretty much all of this data. See, you might be thinking, why we not gonna come have like a smooth curve? See, some kind of a smooth curve. Let's see, smooth curve. Let's see, go like this to cover that pretty much all these data. Yes, we can do. And you might be thinking, why we not gonna go to different kind of, rather than this one, why you not gonna go to that parabolic shape? Parabolic shape, like see, something like this, like that, parabolic shape. Yes, we can go to that one too, but we don't go to those one. We systematically, in this class, we're gonna build up a very broader discussion for what would be the best model. And if you feel like that, in order to explain, this is going to go in every direction, okay? From now on, from here, thumb length can be explained by X. You feel like it's not enough, you're going to add more. You're going to add more. If you keep one variable, we're going to call this one simple linear regression. Why simple? One X variable. One X, so independent variables. One independent variable because of that reason. Okay. Because of that reason. One X simple linear regression. Linear means that you're going to fit in into a straight line. For time being, we say that straight line. Okay. That's not the case, but straight line regression. If you have a many variables rather than height, you're going to think about, okay, how about the weight? How about the other factors? Male and gender too. You can mix up now. Categorical and then everything for X variable in like a high dimensional form, a high dimensional space. We don't come to that one. We come to that one later on. For time being, I'm going to think about that only fit in one variable and then how to explain the variation of thumb length, how being explained by the variation in height. And if you're going to increase, see, 1 unit of height, how it's gonna that affect to this one called the marginal, you know that. Even in the marginal cost, marginal revenue, marginal profit, you know that how they can be calculate the marginals based on the 1 unit more than being manufactured, more than 1 unit more than being sold. See, you know that one. That the same way here we're gonna talk about this marginal things, which is called the slope. Okay? But we're gonna take into account straight line. This line, I'm gonna say, gonna go through very special point called through X bar as well as Y bar. See? X bar and Y bar. That's called the center. Center. It's gonna go through the center for sure. Now you might be thinking there might be so many points, straight line that can be drawn going through the center, but fitting into this one. Yes, there are so many points. See? You can draw this one, this way, that way, that way. But how could we know that what would be the best one? Because through some statistical procedures, we decided we're gonna get the best line called the best fitted line. Okay, that line has an equation, best fitted line as an equation of the best fitted line is given by not y. I'm gonna call y hat b naught plus b1x y hat. See, best fitted line. This is called estimated y. Estimated y. See? And b naught is what? B naught is nothing but intercept. Means y value when y value means thumb length when x value is 0, when the height is 0. Okay, and if it is negative by any chance, when you run that one negative or doesn't make any sense, we have a remedies. Let's say by any chance if you run this one and then you with based on your data you're going to get a negative value, you feel like a what that means. How come when the height is 0, how come the thumb length is negative? You still have a remedy. What are you going to do? You're going to just then the centering means you're going to shift that one. That means you're going to subtract the average from all the thumb lengths, average, and subtract and shift this center, this point to that center, this center. You're going to shift it and then work with a new framework. I think we did that kind of stuff even in our class. But anyhow, that if the situation for some kind of some problems that if you see negative, we can remedy that one too. Okay. And the other one is called B1 is nothing but the slope. Slope is nothing but rate of change of y with respect to x. That means change in y per unit change in x. If you want to write in the context of the given problem, you can say that change in thumb length per unit change in height, or you can simply call this one marginal y. Marginal. Physical interpretation, econometrical interpretation, and mathematical anything. Anyway, you can talk about that. See, that's the slant of this line. You see, this line has a. You get this line here. Now you're gonna see that. See, I'm talking about this line. See, but your data is here. Your y is here. This is your y hat. Y hat. This is for some kind of a x value. Okay, this is x. This is y thumb. This is x height. Is the fitted line y hat equation b naught plus b1x. Would they give the answers b naught and b1? Yes, when you run that one, they give the answer. When you run regression, they give the answer. You can see down the road. How do you do that? But we're going to talk about that. See, GLM. See, MPG has been explained by the engine size. Do they give the answers for B naught? Yes. See, B naught and B1. You can get all these. Then again, we have a standard error. You have to be careful. They also have a standard error. There's a reason for that one, because they were varying, because they're not related to, theoretically not related to one sample. Theoretically, all these gonna change. That's why statistics a little bit tricky, but doesn't matter. We can handle that one. Okay, we don't have to worry about anything. We're gonna plug in this value here and then get the best value. We have a B naught value in numbers plugging over there. Again, then you say that you pick one of the y value. That means thumb length for a given any height. Okay, look at that gap. Again, call the error. See, error. That's the error. In addition to that one, you know for sure there's another guy operating here. That's y bar. Y bar operating all the time. Grand mean operating all the time. See? grand mean. I sorry, that's not the right place. It's not right. It's not right at all. I'm gonna draw this one in a different place, like this. Grand mean. Okay, why grand mean. Okay, this somewhere. Okay, I do. Hold on. I'm gonna do this one a little bit. I'm gonna pick a different place. I'm gonna draw this one clearly to make sense. Okay, this one, right? This line. Okay, let's draw this one first. Okay, this is your center. You know that one. Okay, this is your X bar. This is your Y bar. Okay, that's the center. It's gonna go through the center. I'm picking this Y bar is grand mean. Okay. This line is y hat. Y hat is b naught plus b1 next. Okay. I'm gonna pick a point from here, y. Okay. Then y minus y hat. See, this point is y hat. This point is y bar. See, look at the gaps. So y minus y hat. This one is y minus y hat is error. Y hat minus y bar called, see, this gap due to regression. That's the regression due to model. That gap, that deviation. See, that deviation. See, this deviation due to error. See, due to error. In addition to that one, there's another gap. Look at another gap. The gap is from y to y bar. See, the total due to total error. Total error. Error. Or we're gonna call that an empty model error. Empty model error. Okay. If I draw that one only here for you to see clearly. Okay. Without taking. So this one to here, and this one to here, and this one to there. See, this is y hat, this is y bar, this is y. You have y minus y bar. See, y minus y bar. And you can square that one and sum them up for all the points. And the same way you have a y hat minus y bar. See, this gap, y minus y hat minus y bar, that gap. This gap, y minus y hat, that gap. This gap, y minus y bar. Three things. So this one also I'm gonna square and then sum them up for all the points. And this one add to y minus y hat square. That will equals to this one. See, okay. Y minus y bar square, y hat minus y bar square plus y minus y hat square. Same thing. This is nothing but we call the SST, total sum of square. The second one we call this regression. Third one called the error. See, this one I'm going to write very clearly. Sum of square total. This one called the sum of squared regression plus the last one is called the sum of squared error. Sum of squared error. error. Okay, the last one is sum of squared error, sum of squared regression, sum of squared error. This one is same as this one. That's the one you're gonna see in this table down the road. When you run, see, sum of squared model means regression, sum of squared error, sum of squared total. See, this table playing a heavy role in regression. See, then I'm gonna put this one into some kind of a table called the analysis of variance, which is abbreviated as or acronym ANOVA table. See, ANOVA table. I'm gonna write here source. How do you get the error? How do you get the deviation? Due to what? Model or regression. The other one due to error. The other one is total. See, total. Here we're gonna write something called DF. I'm gonna write here. DF stands for degrees of freedom. We talk about that one earlier. Freedom. Okay. Then little bit that finish this one and we can stop, and then I can continue even Wednesday during that office hours and then go through that homework. Okay. So this one, I need the degrees of freedom of regression. Look at, go to the formula. Regression. Always. How do you get that? And then degrees of freedom of error, how much would that be? Degrees of freedom of total, how much would that be? Degrees of total, this one, if you go over here, look at, I have utilized only one data point. I have n many data points for y. So your degrees of freedom is n minus 1 always. This one, look at here. Go to error. Y hat, how many? Y hat means like your model, this model. See, the model that I wrote over there. See, this is the model. Look at how many, see, coefficient. Those are called B0 and B1. I'm gonna write over here, regression coefficient. Okay. These are together called regression coefficients or parameters. How many coefficients we have? 2. Okay. I'm gonna go ahead and see 2 in this case. That number of that one I'm gonna denote by simple p. I'm gonna call that one here. Simple p means number of parameters in the regression model. In our case, we have a 2. That's okay. I'm gonna write for the general case. Okay. So this should be n minus p. This one is what? This one is nothing but number of x variables. That's it. X variables. Okay. That's why if you go to this table, I'm going to tell you over here, that over here, in this based on that what we have. See, number of regressive variable only one x variable. X variable is what? Engine size. This is y. Okay, 1 x y x. How many data points we had? 428. How many parameters you have? B0 and B2. So 428 minus 2, which is 426. N minus 1. N is 428 minus 1, 427. If you add these two, they should add to that one. For any case, I'm giving this one the general formula for you to utilize for any case. It's easy. See, this one is 1. In this case, 1. Okay, simple linear regression is 1. Then you have a something called sum of squared. See, SS. SS means sum of squared. That means sum of squared regression, sum of squared error, sum of squared total. Then you have something called mean square. MS stand for mean square. I talk about that one now. Mean squares. So this one is mean squared regression is nothing but sum of squared regression divided by the degrees of freedom of regression. Okay, that means in this table, this has been divided by, see, this has been divided by this number. That's why same number. How do you get this one? This divided by that number. You don't need the third one. Okay. So then I'm going to write this one here. So this one is mean squared error is nothing but sum of squared error divided by degrees of freedom of error. Then you have something called F. F is very easy. F, I'm going to call that an F naught is mean squared regression divided by mean squared error. See, that's how you got that one. See? Then you divide by this by that, you get this one. And how do you get this one? I explained that one earlier. Then you go to the F distribution. And this is nothing but probability. This is called the p-value. P where I'm going to say p where probability F greater than F naught. See? F naught. By looking at this one, you decide whether that your regression model is the regression, you have a regression model or not. That means simply, okay, we do that one in the laboratory through an example, then you can see very clearly. But since that we have to lay down a foundation, okay, sorry, here, see, whether this would explain engine size would affect to the MPG city, that mileage in the city, mileage in city being explained by the engine size. See, higher the larger the value of this one, would that the larger the value of this one, or vice versa? Or would this explain the MPG city, the mileage per city can be that determined through the engine size? So do we have to add more? Yeah, later on what they did was, they seems that it's not going to do a better job. They added more. See, engine size, wheelbase, and horsepower. Those are called multiple regression, as I mentioned over. Now we have added, see, variable. That's all. Then we're going to talk about their all the properties throughout this whole course. So mainly that the regret, this one we built up already. See, systematically without your knowledge, I already built up this one. Only thing I have to do just to go through the example and then reinforce what we talk about over here. That's all. See, whatever. Then while we're going through again and again, we're going to talk about that one again and again. Number of X variables, P, see, or you can say number of X variable or number of regressor variable. Another way to people call this one, see, DFR, they say number of regressor variable. Regressor or X variable, I'm sorry, X variable, that's the same name, okay? Variables or number of extra parameters than in empty model. Okay, that's another way to look at that. And remember, in the empty model, you have B naught only. Then you added V1 to regression model. So that's one. You can look at that way too if you want. See, in the empty model, you had a B naught. You can remember. This is nothing but in empty model. If I go back to empty model barely key role, heavy role. Empty model, I would say this Y bar has another name. I would say that Y bar is nothing but B naught. Okay, I can call that one B naught as well. Okay? This one is B naught. If you want, you can write this one Y equals B naught plus E. Okay. Here then if you want that Y hat for this one, you can say Y hat is B naught. Okay, error part is taken out like the way that I did in regression. When come to Y, you have error. When come to hat, you don't have a error. That's the same thing in the second model. I didn't write it down. I straight went to the regression model. I went to this one. See here, if you want best fitted line, If you want I'm gonna write one thing here for you to clearly see. Okay. Simple. Okay, I'm gonna write clearly. Simple linear regression. Okay. I'm gonna say first one model. If you write like this, y. Okay. This is the proper way of writing. Beta note. I'm gonna add another one now. You might be thinking that why we add this one. That's the population version. This is called the error. Okay. This is another way I'm gonna call the population version. This is beta node, beta 0. This one beta 1. Okay. Same thing that we wrote that one. And then I'm gonna write its counterpart b naught plus b1 x plus e. This is called the sample version. Okay. If you're gonna write properly. Sample version. And the second one, estimated line in population, you're gonna write this way. I'm gonna explain that one next time. Expected value e of y. I'm gonna say expected value. Expectation of beta naught plus beta 1 x. In sample version, you're gonna write y hat equals v naught plus b1 x. So you play with this one. If you want, you can go with the model. This one. This is the population model. This is the population fitted line. See, look at that. So you mainly work with this one. See, this guy. This is the one you mainly focus on. But you have to distinguish what I'm talking about. If you need the model, you write with the this letter is epsilon. Epsilon represent error. E represent error too. Sometimes people prefer to call that one residual in sample version. That's the same thing. Residual low error. See, these are beta node, beta 1 beam. See, so in another way, these are estimate of this guy. See, beta naught is beta naught. Sorry, B naught is an estimate of beta naught. V1 is an estimate of beta 1. That's the idea. Since you cannot access the population parameters, you work with this model or its estimated value. See? Here they say that in a long run, expected value. See, expected value. See, so you mainly working on this one. So that's why you have to get everything very clear. See, mainly that we working on that one. We're gonna go through the example and then we reinforce what we learned. And then this is the key part. We've almost built up that regression. Almost built up. We have to keep going because that's the way we have to teach this class. Because we cannot spend too much time for that going through that things. We have to go through the very necessary components only. Then later on, we go through all the examples. And pretty much I cover that chapter 1, 2, 3 is systematically covered today within this short period of time. What I'm gonna do on Wednesday while we going through the example. Example means like our homework. I explain more, and then let's try to find, and then we'll recall and say, hey, the other day we did this one, and now let's apply that one, and then write the codes and run everything. See, we have everything ready to go. And how could we gonna import data? How we gonna set up data? See, change that all that if you have like a dollar signs and everything, take out, and then plot scatter plots. I mentioned about the scatter plot at a certain point, and then how to run this. See, how to run the test. I talk about this one too. See, everything has been talked. That means this homework means that all chapter 1, 2, 3. And later on, we're going to talk about the properties of the regression in detail. I think that I'm going to plan to that stop over here. Do you guys have any questions for today? We can stop here. And then we can continue on Wednesday. Make sure to that be present on Wednesday because I'm going to go through all these. At the same time, you can try to get this done too. But I'm gonna go through all the homework for you to have a clear idea. With the writing part, then you can write based on that T value and everything. What are these R squared? Everything we're gonna explain. We come to the diagnostic later because we don't talk about the diagnostic, but mainly the ANOVA table. And here we have a two types too. You have to be careful here. See, type 2. See, so many things we have. See, type 1, type 2. Then we have to have like a clear idea why we have a type 1 means what. See, in addition to this one, they're going to talk about this, all the tables. You should know how to explain. Okay. But anyhow, don't worry that you're not going to miss anything theoretically, practically, program-wise, and knowledge-wise, that you're not going to miss anything. I'm going to go through in detail what's necessary to be covered. Okay.
Hey, Professor.
The example we reinforce what we talk about today. Do you guys have any questions?
Hey, Professor.
If not, I'm planning to stop over here, and then you guys have a good night, and then see you on Wednesday at the same time, and then let's continue in discussion. And we have even Thursday too. We can keep discussing because we have plenty of time to finish homework, go through more examples, do a lot of things for this chapter 1 through 3. See? Plenty of time. Okay, we have 2 more days. So, if not, I'm gonna go ahead and stop over here. Okay, then you have a good night and stay safe and be well, and then see you guys on sorry, give me one second.
That's okay. Hey, Professor, can you hear me?
Okay, yeah, please, yeah, okay, sure, go ahead, Thomas and Jonathan, please go ahead.
Can you hear me now?
You can ask. Yeah,
can you
you don't have. Yeah, I can. Oh, I know. Oh, I'm sorry. Give me 1 second. I think I have turned off that speaker. Give me 1 second. I'm sorry. Wait, I'm so sorry.
All right, that's okay. I just wanted, out of curiosity, is the textbook absolutely required? Just because I haven't ordered yet.
That's a good question. Actually, you might the way you might not gonna need it, but I cannot say that not to buy. But
yeah, I get it. I understand.
you understand
Yeah.
on my side. But I
Yeah.
think that if you want, you can go ahead and get it. But there are slides, okay, enough slides for you to get a clear idea about what you're gonna cover in this course. You see,
Sounds
everything
good.
already there. I think that tells you everything what I'm supposed to tell you. Okay.
Yeah, I think that's what I was curious. I was wondering if it was because I know some of the other courses it was recommended, but not absolutely required.
No, not with me.
Classes.
You don't need you. That means with or without the book, we are in a good shape. I'm like a walking textbook. Don't worry.
Yeah, that's great. Awesome. Thank you.
Thank you. Okay, have a good night. See you on Wednesday. Thank you. Okay, go ahead, Angela. Okay, bye-bye. Take care. Thank you.
I was actually just trying to wave you down, trying to help Thomas. But I did have a question regarding the book. I'm gonna try to. Sorry, what were you saying?
Okay, go ahead.
Oh, nothing. It's okay. I don't have any questions.
You don't have a question? Okay, sure. Thank you. Okay, take care. Okay, have a good night.
Oh, I should ask for a deliverable. You for a homework. Do you want us to just send you the SAS file?
Can you remember I show you that if you can put like the same way like this is preferable, but you don't have to waste too much time. Okay, don't make it like the fancy way like this, but it's going to be beneficial for you if you write in a detail. Okay, any way you want, doesn't matter. Give me the SAS file. That's enough too. That's enough too.
We really should just like copy and paste the code and
exactly. Copy and paste the first one and even the results. Little bit show me what you're supposed to show. Not the whole thing. Sometimes you don't have to.
Okay, perfect.
Yeah.
That's
okay. Okay. See you guys on then Wednesday. Take care. Okay. Bye.
What time on Wednesday?
Same time. 5:30. I'm gonna send an email plus announcement too. Okay. You're not gonna miss anything. Okay.
Okay, and on our classes, it says that our class is from 5:30 to 7:30, but is it going to be typically 5 to 8, 5:30 to 8?
Exactly, because of that, I like to go like a 2.5, okay? 2.5. Is that okay? Oh, you want me to stop at 7:30?
No, I just want to make sure that I'm planning.
Okay.
I don't I'm not, I plan all of my drinks for after class, not
Oh.
for middle of.
Yeah, sometimes some in the last class I go to like 11:15 too, but I don't do that one. Okay, don't worry. In a worst scenario, sometimes we go, but
Okay.
anyhow, the maximum like a 2.5. Okay, that's it.
Okay, good to know.
Okay,
Good to know.
take care.
Thank you.
Okay, see you next Wednesday. Thank you. Bye.
8 o'clock.